This is 2.5 homework on the complex numbers and other abstract mathematical symbols. So the point of this section is to try to get you to understand that there are other number systems other than the real numbers, the one we're probably most familiar with. In fact, we're going to do some abstract mathematical systems, which you saw in class. There are an infinite number of them. Varying from this sort of clock arithmetic, right, turning the number line in sort of to a circle, to things such strange as a Rubik's Cube that we saw in class today. So let's take a look at this first one. So these are just complex numbers, and you just add the real stuff together and add the imaginary stuff together to add complex numbers. So like this 2 plus I plus 3 plus 2I is just 2 plus I plus a 3 plus 2i. And you add the real stuff together, so 2 plus a 3 is a 5. And you add the imaginary stuff together, so 1i plus 2i is 3i's. So that's my answer, 5 plus 3i. In part B, 5 minus 3i, you just copy it down, 5 minus 3i, and then remember to distribute that minus sign through. So when you minus a quantity, it's minus 2, and then minus a plus is a minus 7i. And so what I have here is 5 minus 2, which is 3, and then a minus 3i, take away another 7i, so minus 7i is a minus 10i. Remember, I is equal to the square root of minus 1. It's said to be the imaginary number, and it has a property that when you square it, you get back what's inside. When you square the square root, it goes away, and so I squared is negative 1. So now we're going to do some multiplication here, and so now when I multiply through by I times 2 is just a 2i, and then plus an I times an I is an I squared. And so this is equal to 2i plus a negative 1, because I squared is negative 1, and you can leave it like this, that's fine, or you can write it in this form, minus I plus a 2i. All right, remember, A plus B is the same as B plus A. This is called the commutative property of addition. We're not studying that, but it has a fancy name. So we do the same thing here then. Multiply through by the I times 1 is just an I, and then I have a minus, and I times an I is I squared. And so this is equal to I minus, I squared is minus 1, so minus a minus 1. And so this is equal to I minus a minus is a plus 1. You can leave it like this or write it, 1 plus I. It doesn't matter. All right, E and F, these are the ones where we have to kind of FOIL. And so the idea is I just take 1 times 2, and I get back 2. And I take 1 times 3i, so plus a 3i. And then I take I times 2, so plus a 2i, and then I times 3i, so plus a 3i squared. Combine like terms, so 2 plus, combine like terms means you look at for likes. So I have 3i and 2i, they're like terms, so I get 5i. And then remember to replace I squared with what it's equal to, which would be negative 1. And I squared is negative 1. And then this is equal to 2 plus 5i. Then 3 times negative 1 is a minus 3, so you can say minus 3. And so my final answer would be 2 minus 3, which is a negative 1, and then plus a 5i. We do the same thing here. So this is equal to, take 1 times 1, and I get back 1. 1 times a negative 2i, and I get a minus 2i. 2i times 1, so plus 2i. And then 2i times a minus 2i is a minus 4i. Right. A positive times a negative is a negative. Combine like terms, 1, and these will cancel, right? Minus 2i plus 2i gives me 0 i's, and I'm just left with this minus 4i. Oh, that should have been squared, right? 2i times 2i, negative 2i is minus 4i squared. And so I get minus 4i squared there. And so this is equal to 1 minus 4 times negative 1, because I squared is equal to negative 1. And so that's equal to 1 minus 4 times negative 1 is a minus 4. And a minus is a plus, so that's 1 plus 4. And so my final answer for this one is 5. Moving on to the next problem set, what we have here is clock arithmetic. The simplest way to do this is to actually make a clock. So over here, let me make my clock. And I'm going to use a different color for the numbers. And so, I'd have 12 here, 1 there, 2 there, 3 there, 4 there, 5 here, 6 here, 7 there, 8 there, 9, 10, 11, and then back to 12. And the way this works is we think 7 plus 8. All right, so we can start at 7 and we count 8 hours into the future. So 1, 2, 3, 4, 5, 6, 7, 8, and we round up to 3, so this must be equal to 3. And then we have 11 plus 9. So I'll start at 11, and I'll add 9 hours. 1, 2, 3, 4, 5, 6, 7, 8, 9. And so I get back to 8. And now we'll do subtraction, right? So addition, we went clockwise. Subtraction, we'll go counterclockwise. So 2 minus 7, I start at 2, and I'll count back 7. 1, 2, 3, 4, 5, 6, 7. So this is equal to 7. All right, now I have both addition and subtraction. So I just go from the left to right. So I have 6 plus 8. So I start at 6, and I add 8. 1, 2, 3, 4, 5, 6, 7, 8. That lands me on 2. And then I'm going to subtract 3, because it's 6 plus 8 minus 3. So I go to the left, counterclockwise, 1, 2, 3. And so this is equal to 11. Same thing here, 5 minus 6 plus 2. So I'll start at 5, and since it's minus, I'll go counterclockwise. All right, 6 times 1, 2, 3, 4, 5, 6. So that's 11. And then I'm adding 3. So what I go clockwise now. 1, 2, 3. It lands me on 2. Part F, this one's a little bit different because now I have parentheses around the second operation, which means do this first. Right? It has an order of operations. So first I'm going to do the parentheses. So 9 plus 11. So I start at 9, add 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That brings me to 8. Right, and then I have 4 minus 8. So I'll say this is equal to 4 minus 8. And I start at 4 now, and I go back 8. 1, 2, 3, 4, 5, 6, 7, 8. So it's equal to 8. Right, so clock arithmetic, it works just like the number line, but now you're on a circle, and you repeat. You can do this with any numbers. It doesn't have to be 1 through 12. You could use 4 numbers, 1, 2, 3, 4. And you can do arithmetic on this. This has a fancy name. We call this modular arithmetic.